Hi, we are James Sorzak and Brett Pressler. Our project was the creation of a wind tunnel lab for aerodynamics. As aerospace systems engineering majors, we focused on the modeling of a wind tunnel wing interface. Most of our work happened in the ME lab and with the wind tunnel area. This is the wind tunnel's test chamber. This is where students will collect data using the new wing interface. And this is the sting of the wind tunnel. This is where the wing interface will connect to the wind tunnel. The most important thing we had to complete with this project was completing the modeling of the wing. However, time management ended up being the biggest issue in the project. We both had very heavy course loads this semester, so it was difficult to make time for everything. The most surprising thing we learned was how long the small and unexpected things take. We changed our approach by starting all of the paperwork earlier and not just focusing on the model in the beginning.
So the goal of our project was to create a wind tunnel model of a wing, and main things we want to focus on are changing aspect ratio and just ensuring it fits in the university's wind tunnel. And with the changing aspect ratio at the max extension, the wing will be the full span of wind tunnel, which will simulate a infinite wing. So got an airfoil cross section because we want to simulate a wing, and the back piece here, this is how we'll mount it on. We're going to put a tran torque in there so we can really easily slide one end into the airfoil and then the other piece onto the sting. Just crank it down and it'll be secure. On this side we've got through holes through here, and we're going to put pins in there. We'll prevent horizontal and rotational motion while it's in there so the pieces will stay in place. And then the center hole, we'll put a magnet, and it'll connect to the magnet in the extension pieces. And when they're placed together, the pull force between the magnets will be about 5 pounds, which is definitely enough to keep it secure, but also easy enough to swap it out without having to remove the whole model from the wind tunnel. And then we have the extension pieces, which have the same interface on the sides of it, same airfoil cross section, and it is 2-inch in width, and we'll add one to each side and then run the data and plot it so you can see how different parameters change as the aspect ratio of the wing increases. Mainly we'll focus on the drag, as high aspect ratio wings will have a lower drag, and you'll have a magnet on either side, and it can be attached to the main piece, and as well we can also make winglets that will align with this and can be attached to show how winglets will increase performance. Also, since this lab is for aerodynamics students, they will be able to create their own winglet design that will interface with this, and they can attach it, 3D print their own, and see how it works. As for the whole assembly, pretty much described, the tran torque will go into the back of this piece and secure it to the wind tunnel. By far the best method we found to attach to the wind tunnel. Then carbon fiber for these, as it's very lightweight, we don't want to have too much weight. And then the magnets, which are neodymium magnets, which are very strong for this size and will be glued into either side of this wing, and it will 5 extensions total will equal the span of the wind tunnel, will be an infinite wing. Gives 6 data points that they can plot and notice the trend in the data. Some important calculations we had to make for this project were making sure the loads on the wind tunnel force measurement doesn't exceed its limits, otherwise permanent damage will result. So we ran through a MATLAB code. We just plugged in what wind speed we should have and what chord length we should make these wings, because the planform area of this wing will have a very large effect on the total lift force. Drag force is not likely to be exceeded, but still calculated it to ensure that it wouldn't be exceeded. And that was the driving force between the size of the wing and as well as the wind speed we run the experiment at and angles of attack.